This lesson is on layers of the atmosphere. The atmosphere is a blanket of gases that surround the Earth. Probably the best way to describe it. It's like a blanket of gases that are held around the Earth by gravity. Now, us being humans and breathing oxygen and needing oxygen to live, we want to naturally think that most of the atmosphere is oxygen, but it's not. 78% is nitrogen, and only 21% is actually oxygen. So when we breathe in air, we're breathing in mostly nitrogen, then oxygen, and then the remaining 1% is other gases such as argon, carbon dioxide, and water vapor. So we're breathing in a lot more than just the oxygen we need. But, despite the fact that it's not the most abundant gas in our atmosphere, we're still getting the oxygen we need. But when you run across the question, you will in your assignment, the most abundant gas in the atmosphere is actually nitrogen. The atmosphere is divided up into 4 different layers based on temperature. All right, that's important to remember. They're divided up based on their temperatures and the way that temperatures either decrease or increase as you go up through the layer, and we're going to see that in a moment. The 4 layers that we're going to study are the troposphere, the stratosphere, mesosphere, and thermosphere. All right, here we have a diagram of Earth's atmosphere. On the left and right, we have altitude. All right, we have it in kilometers on the left side, and we have it in miles on the right side. And then at the bottom, we have temperature in degrees Celsius. All right, down at the bottom, we have Earth's surface here. All right, we have the troposphere, which is the layer of the atmosphere that we live in. All right, you've probably experienced this before. If you ever went on a trip to the mountains, you probably noticed that as you went up in elevation, that it actually felt cooler, got colder. If you had a thermometer to look at as you were doing this, you could see it. Traveling through Switzerland one time, going up and down mountains over and over, I noticed this in a on a thermometer that was mounted on the inside of the vehicle. You could watch the temperatures decrease as we would go up in elevation and increase as we would go down. So you can see that here as you go up, all right, the temperatures go down. All right, then in the stratosphere, it's inverted. As you go higher through the stratosphere, the temperature increases. Then when we reach the mesosphere, temperature decreases as you go up, and more so than down in the troposphere. And then lastly, in the thermosphere, you have an increase in temperature as you go up in elevation. So it's kind of like a flip back and forth type thing. So in troposphere, temperature decreases as you go up, stratosphere increases as you go up, mesosphere decreases as you go up, and then finally thermosphere increases as you go up. All right, so now let's break down these layers one by one. All right, the troposphere is the layer closest to Earth's surface. It contains most of the mass of the atmosphere, so most of the gases of the atmosphere are located in the troposphere where we are. This is a place where Earth's weather takes place. As I was saying earlier, in the troposphere, temperature decreases as you go up in altitude. All right, and the boundary marking the end of the troposphere, right before you enter the stratosphere, is called tropopause. All right, so here we have the troposphere, and again, reminding you air temperature decreases with height, and then at about 5 to 8 miles high, that's where you have tropopause, and that's where stratosphere begins. So now let's talk about the stratosphere. It is located right above tropopause. It is made of ozone, which is an oxygen molecule that consists of 3 oxygen atoms combined. Most often in nature, or down at least down in the troposphere where we are, oxygen tends to exist as O2, which is 2 oxygen atoms combined. But ozone is 3 oxygen atoms combined into one molecule. Now, due to the absorption of radiation, temperature in the stratosphere generally increases as you go up in altitude. So the stratosphere is good at absorbing radiation, It also has the ozone, which protects us from ultraviolet radiation, and so the heat increases as you go up in altitude. And then stratopause is the boundary where the stratosphere ends. So now we've seen there's kind of a pattern. You have a layer of atmosphere, then you have its boundary, which takes on a name similar to it. So we had troposphere, tropopause, then the stratosphere, then stratopause. And we're going to stop here to talk about ozone a little bit more before we move on. So, as I was saying, ozone is formed by the addition of a third oxygen atom to an oxygen molecule. So you have O3 instead of O2. And the ozone layer, like I said, protects us from UV radiation. Chlorofluorocarbons, or CFCs, can deplete the ozone layer. So this was discovered, I believe, in the 70s, that the use of chlorofluorocarbons in aerosols and air conditioning units was depleting our ozone and causing a hole in the ozone layer. And so action was taken by our government and other governments in the world, and the use of CFCs is more or less banned globally. There may be some places in the world where they're still being used, but for the most part, all developed nations have definitely stopped using these because the threat that they presented was so great and easily identifiable, and something was done about it. Even today, if you buy aerosol cans, you know, something like spray paint or even hairspray or anything that comes in a spray can, usually it will still to this day say no chlorofluorocarbons on it. It'll say CFCs and have one of those little circles with a bar through it over it. And that's the reason why we stopped using them, because they cause ozone to break down, and we need that ozone there to protect us from ultraviolet radiation. All right, so just above stratopause, we have the mesosphere. It is the most poorly understood layer, and that's why I'm not going to be able to tell you much about it, because really not that much is understood about it in the first place. Now, it does not have ozone like the stratosphere does, so temperatures generally decrease as you go up in altitude and go away from those warmer layers. Mesopause is the boundary of the mesosphere right before you enter the thermosphere. So the thermosphere only contains a very small amount of the atmosphere's mass. That means it does not have as much gas in it as the other layers do. It has the least amount of gases, but it's a great deal of our atmosphere's volume. So what that means is it's a very thick layer. It's a very large, thick layer, but the gases in it are very, very, very spread out. All right, the thermosphere, of course, like I said, is located above mesopause. Temperatures increase as you go up in altitude through the thermosphere, and temperatures can reach 1,000 degrees Celsius. Contained within the thermosphere is the ionosphere, which is an area made up of electrically charged particles and lighter gases. Thermopause is the boundary of the thermosphere. Now, we're not going to talk about it today, but sometimes in some books and other sources on the atmosphere, they have another layer they talk about called the exosphere, but that's not one we're going to talk about today. It's not necessary for our purposes. All right, we're going to talk about atmospheric energy. This is going to reiterate and maybe build on some things we learned in our very first unit on astronomy. All right, so the sun is the main source of energy for the atmosphere. It delivers energy to the Earth's atmosphere through radiation, and then it is circulated in the atmosphere through conduction and convection. So we've talked about this before. We've talked about how the sun, the energy from the sun reaches the Earth through radiation, and the surface of the Earth is heated, and then air that touches the surface of the Earth is heated through conduction, and then that thermal energy is circulated in the air of the atmosphere via convection. All right, so with radiation is a transfer of energy through space by electromagnetic waves. Some energy is absorbed by the Earth, and some is bounced back into space. 35% of incoming energy is reflected back into space, 15% is absorbed by the atmosphere, and about 50% is absorbed by the Earth's surface. The energy that's absorbed by the Earth is then given back off into the atmosphere, as I've been describing. So here you have a little breakdown, a little diagram of how much energy is reflected, absorbed, um, as it comes in from the sun. Same deal here, same kind of diagram. All right, conduction is a transfer of energy that occurs when molecules collide or touch. So air molecules touch the surface of the Earth, and heat energy is transferred to them. It only heats the lower parts of the troposphere. This process here of the air touching the surface of the Earth only heats the lower parts of the troposphere. But as you already know, warm air is going to rise as cooler, more dense air sinks. So it's going to get circulated. The conduction is only going to heat air close to the surface of the Earth, but then that heated air becomes less dense and rises, and that's what's going to circulate it to the upper parts of the troposphere. All right, so convection is a transfer of energy by the flow of heated substances. As the remaining energy rises in the atmosphere, it cools and sinks back down to the Earth until it heats up again and recirculates. So you have this ongoing pattern of warmed, less dense air rising, and then cooled off, more dense air sinking over and over again in what we call convection currents and convection cells. So this provides energy to the remainder of the atmosphere. This is what circulates. It's like the last process that circulates that thermal energy all about our atmosphere. And here we have a diagram showing you all three. You can see radiation here. This heat is traveling through empty space in the form of radiation, electromagnetic waves. You have convection here. You have this heated water. The hotter water becomes less dense and rises. The cooler water, because it's more dense, it sinks to the bottom and it circulates in convection cells and convection currents. And then here we have conduction. We have this person who's able to feel the heat through the handle of this pot.